So in this half of the lesson, we're going to talk about the standard normal distribution and how this is different a little bit. So when we're doing just the normal distribution curve, it's limiting in the amount of percentages that we can calculate. Sometimes we can't calculate everything, so we need to actually use the standard normal distribution, and we will use what we call a z-score in the table of, and we have to read our probabilities and off of this table. So the standard normal distribution has a mean of 0 and a standard deviation of 1. So the data value x from the normal distribution with a mean mu and a standard deviation of sigma can be standardized by finding its z-score using this formula. So let's talk about that formula for a second. So z equals x minus mu over theta. This is your mean, always. This is your standard deviation. And this here is the biggest number that they want to find. Okay, so that'll make more sense when we actually do a problem. So the areas under the standard normal curve are to the left of the given z-score. So that's an important thing because there's sometimes we have to find something to the right, and we'll see an example of that in a minute. They're all computed for us in this table. The table allows you to find a greater range of percents and probabilities than just what we were doing earlier. For example, the area under the curve to the left of the z-score 1.3. Okay, so if we're going to try to find 1.3 in here, the number to the left of the decimal point is always here, so it would go to 1. And then the number to the right of the decimal point is always across the top. So I go there, and then I run that down, and I find that the probability is 0.9032. And again, if I had to do percent, I could just move the decimal place 2 to the right. All right, so let's try this in a problem. Unfortunately, the problem's kind of split up a little bit here. So suppose the heights in inches of women ages 20 to 29 in the United States are normally distributed with a mean of 64.1 and a standard deviation of 2.75. So there's two questions here. Find the percent of women who are, it's been percent, no more than 65 inches tall. So that's question 1. Find the probability, different measurement, that a randomly chosen woman is between 60 and 63 inches tall. Okay, so the means, we're going to kind of set up our problem here. So the mean heights is, of all the heights, is, they told us 64.1. And then they told us the standard deviation is 2.75 inches. So we're going to convert the heights to z-scores and use the standard normal table to find the probabilities needed. So the first thing is to find the percentage of women who are no more than 65 inches tall. Okay. So, and I don't know why it just has a solving one. We're going to solve both of them. So I'm going to first calculate the z-score for that. So I know that my biggest number that I'm going to have here is 65 minus the mean, which is 64.1, over the z-score, which is 2.75. And when I do that calculation, I get 0.327. So really what I'm going to use off of that is the 0.3 in the table. I've got to make sure it's rounded correctly, which though the 2 wouldn't round that up. So I'm going to go to my standard normal table again here. Okay, so I'm looking at 0.3. I'm going to kind of erase my scribbles here. So 0.3 would be this value right here. So it is the probability of this happening is 0.6179. But in the problem, they asked me for percent. So I do need to move the decimal places. So 61.79% of women are, what was the question? No more than 65 inches tall. Okay, so that was the first part of the question. And I don't think we really we did the justification and evaluating right up here. So The next one we need to do is we need to deal with the, whatchamacallit, the 60 and 63, okay? So first I'm going to have to convert 60, and then I've got to convert 63. Let me see if I can make this just a little skinny. Okay, convert 60 and convert 63. So my z-score for 60 would be 60 minus 64.1 over 2.75. And when I do that arithmetic, I get negative 1.5. And then the z-score for 63 would be 63 minus 64.1 over 2.75. And when I convert that z-score, I get negative 0.4, okay? So what I'm looking for is what they asked me for in this problem is whether it's between 60 and 63. So I'm really looking for when z is between 60 and 63. And this is just notation for the z-score. So what I'm going to do is I'm going to find the probability that my z-score of 63 minus my probability of the z-score of 60, and that's going to give me my overall probability. So I'm going to go use the table to find those values. So my z-score at 60, I need to go to negative 1.5. So negative 1.5 would be right here, so 0.668. And that was 60, so minus 0.668. And then my z-score of 63 was at negative 0.4. So negative 0.4 is 0.3446. So my probability is going to be 0.2778. And they did ask this time to leave it in probability. So this is the probability that a randomly chosen woman is between, what do they say, 60 and 63 inches tall. All right, we're using the same data for 7 and 8, okay? And this says 66, so I'm going to go and calculate my z-score for 66, which I don't think I have that yet. Nope, we did 65, so I'm going to start with that z-score. So z equals 66 minus 64.1 over 2.75, which is going to get me, I'm going to go 0.6909, which would round to 0.7. So the score from the table, or your probability from the table, is going to be 0.7580. What happened? I put, so I'm not looking, let me look at 7580. I just have it written wrong somewhere. 75, I wrote 84. Okay, 80. I wrote it wrong when I wrote it originally. All right, so the catch here is, though, that this is the people who are at least 66 inches tall. So if I'm looking at the normal curve and my 66 is here, at least would go this way. But what we know about this table is it only gives us the information that is to the left of the number, not to the right of the number. So to get the actual probability, I need to do 1 minus this value. And that is going to get me, I'm going to do a quick calculation. And that gets me that it is 0.242 And they wanted that in percent. So I'm going to move my decimal place. So 24.2% of women are at least 66 inches tall. Then we want to find the percent of women who are less than or equal to 61.6. So let's do our z-score. So 61.6 minus 64.1, the mean, over the standard deviation of 2.75. And I've got negative 0.909, which would just be negative 0.9. I'm going to go to my z table and look that up. So negative 0.9. So negative 0 and 0.9 is here. So 0.1841. So the probability is 0.1841. But this time it asks us again for percent, so I'm going to move the decimal place to the right too. So it would be 18.41% of women are less than or equal to 61.6 inches tall. That's the end of the lesson, so make sure that you go through and you answer your 3 elaborate questions as your summary.